Assalamu alaikum. So let's continue from where we left last week. We were talking about the fundamentals of cloud computing, and today is finally the last lecture of the series. So far, we have um, we have covered the basics of cloud. What is cloud computing? What is the difference between a hybrid cloud and a public cloud? um, and what are the different services that they offer, like the infrastructure as a cloud and software as a cloud and platform as a cloud, the benefits, the advantages and disadvantages of that. We have also looked into a live lab in which we saw uh, um, the construction of a virtual machine, and how to create a virtual machine, how to enhance the space of that virtual machine, how to create an image of the virtual machine, how to create a virtual machine out of an already created image. So we have seen all that. So in today's lecture, we are going to conclude this series with the following topics. We will look into the regions, the Azure regions. We will discuss the Azure availability zones and Azure availability sets. We will talk about Azure containers, and finally we will discuss the networking in Azure. So yeah, let's start. So first of all, Azure regions and availability zones. So we need to understand that the infrastructure of Microsoft Azure is spread all over the globe. It's spread all over the world uh, in various geographies. So what is a geography? Geography is basically just a logical boundary that Microsoft has defined, and they are often defined by the borders of that particular country. So what's the use of that boundary? What is the benefit of that boundary? So these boundaries actually allow Microsoft to assure that the data centers comply with the regulations of the particular country that they are located in. So for instance, there are data centers in UK, and somebody in Middle East wants to use the to to use the Azure services, but if the data centers are only in UK, and not in Middle East, then there may be some regulatory issues. We have discussed this in the previous lectures. So that's why Microsoft has divided the whole globe into 54 regions, so that those regulatory issues can be tackled with. I mean, one of the reasons, not all the reasons, but just one of the reasons of having the geographies and regions is to comply with the regulations. Um, so now within each geography, Microsoft has defined two or more regions. Region is also a logical boundary, but it is much more than uh, localized than a geography. So each region within a geography is typically separated by 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 some hundreds of miles, so that if there is a disaster, uh, then one region will not impact the other region. I mean, if in United States, there's a region, west region, and there's a north region, and there's south and east region. So there must be like hundreds of miles of distances between these regions, so that if there are um, wildfires or earthquakes in California, New York should not be affected by that. Obviously, it will not be affected because of the difference of thousands of miles. So that's why they keep it. They they distribute the regions and the geography in such a way that the natural calamities are not impacting the whole infrastructure at one go. Now, in each region, Microsoft has built data centers. Uh, so, what does data center have in them? The data centers have got uh, the physical hardware, uh, climate control mechanism, dedicated infrastructure, and power generation systems, so that the data flows in and out of those data centers through the leased cables and the fiber optic cables which are owned by the Microsoft. Um, Fiber optic cables in some cases uh, go through the bed of the ocean, the ocean floor, because obviously, these data centers are connected with each other as well, and and when the regions, they are separated by the sea and by the oceans, then they are connected by the virtue of those um, fiber optic cables which are connecting the data centers with each other. So Microsoft recommend the customers to replicate their data in multiple regions to ensure maximum availability. And this is because, if the service is disturbed in one particular region, then at least the data can be accessed by by a different region, because you know the data has been replicated across multiple regions. So to protect your data in applications from a localized problem that might happen at a particular data center, Microsoft created something called availability zones. Now, each availability zone is a unique physical location in a region. So you have regions, and within regions, you have something called availability zones. Now, each availability zone um, contains one or more data centers. So um, the the way these availability zones are created is that they do not share the water, the power sources, and the network infrastructure between each other. And again, this is to ensure that if one availability zone is impacted, then there is another availability zone which is going to support the subscribers. Uh, in case of a natural disaster, because if the power and the water and the electric supply and the other infrastructure is same between a number of availability zone, that it will kill the purpose. There's no point of having the availability zone, because if there is one disaster because of which the power is cut, or because of which the water supply is cut, and those power and water supply are supplying to multiple availability zone, then those multiple availability zone will be impacted. So that's why they say that they don't share all these water, power sources, and the infrastructure, the network infrastructure. Uh, so Microsoft offers 99.9% availability if you have two or more VMs deployed in two or more availability zone. So if you have created VM to, for instance, support to um, to create a web server. So the advice is that don't create just one VM, create multiple VMs, at least two VMs, and those VMs should be in two different availability zones, um, because of and so that if there's a disaster, then you don't lose everything. You don't lose that that VM of yours. So so this is all about the Azure regions and the availability zone. Now let's talk something about availability sets as well. Um, you remember that in the last lecture, those of you who were present in the lecture, they must have seen me creating the virtual machines from the scratch on the Azure portal. If you haven't done so, if you haven't seen that, then you can go to the YouTube video that I've uploaded on the continuous learning page. So in that video, you have seen the creation of a virtual machine. Now, what happens when a virtual machine is created physically? Uh, Once Azure has finished deploying my virtual machine, there is a physical hardware rack somewhere in the data center. I mean, if we are creating that in Europe, then a physical hardware rack somewhere in the Europe data center that contains a host computer of my VM. So, so it's just like I mean, on the screen you can see a number of racks. So, one of the physical hardware in those racks is going to be used to create your virtual machine. So this also means that there is a point of failure for my VM. Now, so why we are calling it as a point of failure? Because if anything goes wrong with the power or with anything else in that rack, which is accommodating my VM, uh, then the services that we are running from that VM, they are going to be impacted. Um, and so that is one risk. There's another risk, which is uh, if I am running an IaaS service, infrastructure as a system service, then I am the admin of that VM as well. And being the admin, it is my responsibility to keep the operating system of my VM updated. So in a way, um, it's actually helped me because it means that I should always be aware if the operating system update uh, is going to reboot my system and impact my availability or not, because I'm the one who is keeping an eye on the operating system all the time, being the by being the admin. But the OS update is not the only thing that will cause the machine to reboot, because obviously, you know, when you install the updates of the operating system, in most cases the system needs to be rebooted. And obviously, when the systems are rebooted, they will have an impact on the availability of the services that you're running from those systems. But again, these operating system updates are not the only reasons to, you know, to for the machine to be rebooted. If Azure determines that my VM has got some problems, it is unhealthy for any reason, then Azure is going to take a decision and it's going to reboot the VM to bring it back to a healthy state. And such a thing may happen without even giving you a notice. I mean, because for the updates, you usually have a notice that, okay, we have installed these many updates or these many software revisions on your operating system, and you know, the system notifies you that that is going to take a reboot in a number of hours, and you can delay those reboots as well. But in this case, when there is a fault, then the reboot can happen anytime on its own. Uh, so Azure may also reboot the host operating system if an update is required, and it can uh, it can also happen without any notice if there is a fault. So in these scenarios, when there is a reboot because of the update or because of and there's a reboot because of a fault, availability sets help us to avoid downtime in this situation by using uh, two logical containers called uh, the fault domain and the update domain. Now, a fault domain is designed to protect us from the hardware issues, uh, such as the power issues in the physical rack, or something else, some corruption in the software of your virtual machine. So anything to do with the physical stuff, uh, you have your fault domain, which is going to protect you. And an update domain is actually going to protect you from the downtime due to the machine, either uh, the host computer or the virtual machine that it is on being rebooted. So these are the two domains that are there to protect you um, from the reboots, which may impact your availability. Now, as you can see on the screen, um, on my left, I have 5 VMs, and when I created the first VM, Azure placed it in FD0, in fault domain 0, and the update domain 0 as well. Now at this point, I have no fault tolerance and no update tolerance from a reboot update, because obviously there's only one VM, and that VM has been placed in the fault domain 0 and the update domain 0 as well. But when I create a second VM, Azure places it um, in a different fault and um, update domain. So a VM that is placed in a different fault domain is actually hosted in a different physical rack, not in the same rack, and that provides a fault tolerance, because obviously if something happens to the physical rack number 1, then and it contains both the VM, then both the VMs will be impacted. So that's why when you created two VMs, one of them is created in fault domain 1. I'm sorry, in physical rack 1, and the other one in physical rack 2. Now, the update domain protects you from the availability issues caused by the reboots, because Azure will never reboot computers that are in a separate separate update domains at the same time. So now you don't tell Azure that which fault domain and which update domain your VMs are going to lie in. This is something that Azure determines itself. It is going to make a decision on its own that okay, you are creating VMs, and to ensure that you have the availability and the fault tolerances, the system is going to decide itself that where those VMs are going to be placed in the availability sets, so that you have fault tolerance from the physical faults, and the update tolerance from the reboots, which can happen to update your software and your operating system. So that was the bit about the availability sets. Now let's talk about the Azure containers. Let's talk about a feature in Azure Compute which makes it possible to deploy many complex applications to the cloud much more efficiently and much more easily. So this feature is called as containers. You may have um, you may have heard people saying about Azure Kubernetes service and the Azure App Services, Azure Container Services. So these are all supported by the feature called container. So now think about what you need to do if you want to deploy a complex application to a virtual machine running in the cloud. You need to install database components. Uh, you will have to configure all the settings. You will have to ensure that your database drivers needed by the applications are installed and they're all working correctly, and so on and so forth. So what happens when you want to deploy the same application for a second VM? Do you want to go through the whole process? I mean, we have seen creating the VM in our last lecture, where it was a very simple VM. We did not go for you know uh, the, the sophisticated drivers being installed in that. There was no databases. All we did was that we created a VM, and it took us around 2 to 3 minutes to create that VM. It's not a lot of time, but imagine that we had to install, a few databases and a few settings on that VM, and somebody came and asked us that to do the same process again for 10 more VMs. Then it's going to be a no-brainer job, but it's going to take some time, and there's a uh, there's a chance of making mistake as well, because you may omit some setting, um, just by mistake. So what's the solution for that? The solution is that containers are there to make such deployments much easier. So for example, on the screen I'm showing a Docker container, uh, because Docker is one of the most used containers, and this is how it works. So you create an image which is essentially a zipped image of your application. Now that image may contain an operating system. It can contain the application itself, uh, and any files that it requires, any necessary modules that the application requires to run, uh, any database components that are required by the application to work correctly. Maybe the application uses a web server, so it would have that web server along with the web server configurations, and then it may also have the application websites. So all that stuff is going to be zipped into an image. Now anything else that the application require, that is also zipped into that image. Now in order to run an application in a container, you need the container runtime installed in it, right? So the most popular container runtime at the moment is Docker, which is created and provided by a company called Docker Incorporated. It's represented by that fish in the water, which is shown on the screen. So when you point that particular Docker runtime to your Docker image, when it gets usually stored in a website called Docker repository. So Docker creates an isolated environment called a container in which you run your application. So you have your image zipped into a file. There are, so that zip file contains your application, your settings, your your configuration, your web server configuration, and then on top of that you create a Docker runtime or a container runtime, which points towards that image. And collectively, this is what uh, you call as a container. So now you can think of a container as something similar to a VM, something similar to a virtual machine. Now the containers make it easy to deploy your application, uh, and all it um, the application and all the dependencies of that applications to the cloud. In Azure, containers are supported in Azure Kubernetes services, Azure App Services, Azure container instances, and the Azure virtual machines. So these are the things in which uh, your Azure containers come into play. So now, finally, we are going to look into your um, networking part of Azure, and this is going to be the last topic today. So as we are looking at the networking products, we are going to use something called N-tier application, which I am trying to show here as an example as well. So now, while it is not a requirement for us to design the application using this model, this is not the only model, but most of the application do use an N-tier approach because it makes it easier to separate the components of the applications from each other. So in this example, we have something called a web server. No, sorry, we have called a web tier, which provides the user interface to the application. We have a middle tier where we have some business logic defined, and we have a data tier that deals with the data that the application uses. So for security reasons, you would typically want to make sure that only the web server is exposed to the internet, and you would also want to ensure that the web server exposed to the internet cannot talk directly to the data tier over the network. So that's why you can see a separation between your web tier and your data tier. Yeah. So instead, all the data is exposed to the web tier through the middle tier, um, and that's why for security purposes, you have your middle tier in between your web tier and your data tier. So now to enforce these kind of best practices, we can use Azure Virtual Networks to segment my network into the subnets. Uh, so so this graphic shows the same N-tier application, but now I have an application with an Azure network, and I have created 3 different subnets. You can see that subnet 1, subnet 2, and subnet 3 are created within the virtual network. And by using these subnets, I can apply rules that controls the network traffic that flows between the subnets. So there's something called virtual networks that we haven't discussed so far. Virtual network is a mechanism by which the virtual machines talk to each other. You can imagine it like a local area network in your offices, where the computers are connected to each other. They are not connected to the internet, but to each other through a local area connection cable, and they can still talk to each other um, in a secure manner. So that's the same thing. That's the same concept which is used in Microsoft Azure as well, where they have uh, virtual networks which connect different virtual machines with each other so that they can talk, and they are separate. And as shown on the screen on the left diagram, they can be separated by different subnets, uh, just so that you can implement um, the networking. So yeah. Now, if I have 3 VMs running my web tier, so that I can maintain a high availability, rather than just using a single VM, for a service, I decide to have 3 VMs for a high availability. But there is a problem with this configuration, because each of these VMs will have their own public IP address, and any particular user of my application is only going to use one of the specific VMs. So if that VM all of a sudden is under a lot of load, then what's going to happen? Um then that can cause that user to experience slowness of errors. I mean, sorry, it can cause slowness, or it can cause some error from my web application. Uh, it would be therefore much more ideal if I could just spread the load across all of these VMs, so that all my users get a really good performance. The Azure Load Balancer therefore is a product in Azure networking that will make it possible. Uh, so in this graphic, I have added the Azure Load Balancer to the mix. Now, instead of uh, a user seeing the IP address of a particular VM, everyone that uses my web tier sees the IP addresses of the Azure Load Balancer. So it's not going to uh, to recognize the VM's IP address, but it's going to go to the IP address of the Azure Load Balancer. And not only does Azure Load Balancer distribute the traffic evenly across the VMs, but it can also be configured so that it sends a user to another VM if a problem is experienced with one of these VMs, and that user won't even know that that's what is happening. So let's have a look slightly deeper into it. What if I want to send my traffic um, to a specific VM based on the URL, or what if I want to do something like using a cookie to ensure that the user always get directed to a same VM? Maybe I am storing some confidential information on that VM for that user, and I want to make sure that they don't get moved to a different VM. Or let's say that I want to create a custom error page that might have my company's logo on it, or it may be that I want to offload um, the handling of some traffic from my VMs, so that they don't have to deal with that uh, um, overhead. Now, to do all of these type of things, I need a load balancing solution that understand the HTTP, which is the language of the web. And thankfully, Azure has just such a project. Um, Azure has got such a product uh, that's called Azure Application Gateway. So in this graphic, instead of using Azure Load Balancer, I will be using the Azure Application Gateway, and it does a lot of same things for me that Azure Load Balancer does, but it also understands the HTTP traffic, and it can fulfill the other requirements that I talked about earlier that deal with specifically with the web traffic. And even better, I can add other networking product called web application firewall to my application gateway, and that can help prevent the bad guys uh, from accessing my virtual network across the internet. So with this, um, I'm going to conclude today's lectures. This lecture was admittedly a short one, but it was an extension to what we discussed in our last lecture, because of course, so this is all done. Now we have got some understanding of what cloud is, and what are the features, what are the applications, what are the um, what are the availability zones and regions, what are the availability sets, and how the virtual machines are created, and all that. We have all discussed. We have discussed it in the last 4 lectures. So if you have any questions, please feel free to ask. I'm just going to stop the recording.